Hey guys, it's Ms. Johnson and I'm here to bring you our second video for Unit 3. Today we're talking about adding and subtracting polynomials. So when we add and subtract polynomials, we add polynomials by combining like terms. That's really all we're looking at for adding polynomials. So we combine our like terms. Always make sure that you write your answer in standard form, which means you decrease those exponents starting with the largest one. Let's just look at a couple examples. If I look at number 1, this is kind of similar to what we did yesterday. We're just going to combine like terms here. So that means I'm starting with the largest power. I see that that's a power of 3. So I put those two together. I have a positive 2 and a positive 8. That's 10x to the third. So that's gone and that's gone. Then I look for my power of 2's. Here's a 3. Here's a negative 5. 3 minus 5 gives me a negative 2x squared. So that's gone and that's gone. Then I would look for the power of 1, and here I have a negative 7 and a 4. Negative 7 and 4 is negative 3x. And then the last one, 12 minus 5, gives me a positive 7. So I have 10x to the third minus 2x squared minus 3x plus 7. If I look at number 2, again, I just have a whole bunch of terms strung together here. I want to just combine the like terms and put them in standard form. So I'm going to start with the largest power. My largest power is 7x to the third. And that's the only one that I have, so I didn't have to combine it with anything else. Then I have x squareds, so 3 minus 2 gives me 1. So I have plus 1x squared. And then the negative 7 and negative 9x would come next, so negative 16x. And 9 and 11 gives me 20. Now, I want to point something out. I mentioned this yesterday, but you don't technically have to write this 1 in front. If this were a multiple choice test or a standardized test of some sort, you would see it like this. So that's how my answer would look. Now, we have two ways of adding polynomials. When we have polynomials that we're adding together, it's kind of like having one group of terms plus another group of terms. So we can add this horizontally. And what we would do if we add it horizontally is we would just line up the terms straight across and combine like terms, kind of like what we just did. So when I combine like terms here, I have 4x squared and 2x squared gives me 6x squared. 3x and 2x gives me 5x. And then negative 2 and 1 gives me negative 1. So that would be my solution here, or my simplified form of the expression. We can also add them vertically. So if you wanted to add them vertically, we would line up the like terms in columns. So my x squared would go over my x squared. The x term would go over the x, and the constant would go over the constant. So any like terms that you have, you could put them in columns. This goes back to multiplying like we had like we did way back when we were little. We would line up those like decimal places, we'd put them in order. Now we're just doing it with variables. So we can do it this way and add straight down. So 4x squared and 2x squared, that's where you can see that I get that 6x squared. 3x and 2x is 5x, and negative 2 plus 1 is negative 1. Okay, so I get the same answer. It doesn't matter which way you do it. Some people like horizontally, some people like to line them up vertically. All right, so let's do a few examples on the back. So on the back, I'm looking at 3x squared minus 4x plus 8 and 2x minus 7x squared minus 5. Now I will do this first one horizontally. I'm just going to look for the like terms that I have. So I have 3x squared and negative 7x squared. 3 minus 7 is negative 4. So negative 4x squared. I'm done with those. And again, you don't have to cross them out when you're finished with them, but if it helps you keep your work organized, go ahead and do that. Then my x terms, negative 4 and 2 is negative 2x. And then my constants, 8 minus 5 is 3. And that is my simplified form of the expression. Now I'll look at number 6 vertically. If I line my terms up vertically, be very careful here because in this second one is actually not in standard form. So I would need to switch the order of these two. So I'd have 5x squared minus 3x plus 4. And underneath it, I'd have that negative 3x squared plus 6x minus 3. those are the things that I'm adding together. Now my like terms are in columns, and I can go from there. So I have 5 plus negative 3, or in other words, just 5 minus 3, which is 2x squared. And I have negative 3 and 6. Negative 3 plus 6 gives me 3. And 4 minus 3, or 4 plus negative 3, either way you think of it, you get a 1 there. So 2x squared plus 3x plus 1. So when I subtract subtracting polynomials, I need to make sure I distribute the negative that's between them to each term behind it. Then I go back to just combining like terms. So this negative that would be between polynomials goes to every term that's behind it. It doesn't affect the things in front of it. The things in front of it stay the same. But each term behind it needs to be multiplied by -1. It's like having a -1 that you're distributing. Basically what that does is each term behind the subtraction sign will be its opposite. If it started positive, now it's going to be negative. If it started negative, now it's going to be positive. Then I can go through and combine my like terms like I do with adding. So when we're subtracting polynomials, I'm going to distribute this negative to both terms behind it. And what that does, the first one stays the same, the middle becomes adding, and the second one becomes negative 2g to the third minus 4g. So now I'm just back to adding, and all I need to do now is combine my like terms. So I have a 4g to the third and a negative 2g to the third. 4 minus 2 gives me 2. So I have 2g to the third. Then I have negative 5g minus 4g, which is a negative 9g. And that is my simplified form. So in number 8, I distribute that negative. If I rewrite the whole thing, 3n squared plus 13n to the third plus 5n, that stays the same. But now I am adding negative 7n minus 4n to the third. So those two behind it became its opposite. The 7n is now negative 7n. The 4n to the third is now negative 4n to the third. Now I put my like terms together. I like to start with the largest power so that it's automatically in standard form. 13 minus 4, because I have a 4 into the third over here too. 13 minus 4 gives me 9, so I have 9n to the third. Then I have this 3n squared that's by itself. And then I have the 5n minus 7n, which is negative 2n. Let's take a look at number 9. Now, once you start to realize what's happening with these subtraction symbols, if you want to just, instead of rewriting the whole thing, if you want to make this a plus and then change everything behind it to its opposite, that's fine. You've taken care of that. So I make the middle adding, and then I change everything behind it to its opposite. So that 4 that was positive became negative, that 9 that was negative became positive. And then you don't have to rewrite the whole thing. It might save you a little bit of time. If you can keep your work organized, then that's fine. So I'll start with my square terms. I have 5y squared and negative 4y squared. 5 minus 4 gives me 1, so I have just y squared. And then my y term, there's just one of them, so minus 3y. And then my constants, 8 and 9, gives me 17, so plus 17 there. Again, in number 10, if you want to, if you can keep yourself organized, you can just do adding and then minus, plus, minus. So now I'll go back and put my like terms together. I have a 3x squared and a negative 4x squared. 3 minus 4 is negative 1, so that's just negative x squared. You don't have to write the 1, but you can if it helps you. Then I have this term that has an x and a y. So that would be my next term in standard form. We're not used to seeing things with two variables, but technically this has a degree of 2. So I would put that next to my other degree of 2. So negative 8 and negative 6, that's negative 14. So negative 14 xy. So I'm done with those. And then I have this negative 5 and positive 2y, and those have degrees of 1, which is why I'm putting them last. So negative 5 plus 2 is negative 3y. All right. Number 11. So now we're getting into a word problem here. It says the total number of public school teachers, T, consists of two groups, elementary E, and secondary S. From 1992 to 2003, the number in thousands of secondary teachers and total teachers could be modeled using the following equations, where n is the number of years since 1992. Okay, so we're given two equations here. We are told that the secondary teachers, this S, is 29n plus 949. The total teachers, this T, is 58n plus 2,401. The question is, find an equation, that should just be one equation, find an equation that models the number of elementary school teachers for this time period. So if I know the total, I can get the elementary from taking the total minus the elementary. That is how I'm going to get those elementary school teachers. Take the total, subtract the secondary, and then I'll get elementary. So what that means is I have elementary school teachers is equal to my total, plug that in, make sure you put it in parentheses, 58n plus 2,401, and then subtract the secondary, and again, make sure you put it in parentheses. If you didn't put that in parentheses, you might forget to distribute that negative that's between them. So what I need to do here is exactly that. Distribute the negative that's between them. That makes that a negative 29n and a negative 949. And that's the piece that gets forgotten about. Most people remember to subtract the first one. They forget to subtract everything else that's behind it. So now I put these like terms together. So I have 58n minus 29n, which gives me a 29n. 58 minus 29 is 29. And then the 2,401 plus negative 949, or in other words, just 2,401 minus 949 is positive 1,452. And you can always be checking these things on your calculator with me to make sure that you're getting the right answer and also to make sure I'm getting the right answer. So that is the expression for our elementary school teachers, which is why I labeled it teachers. And that takes us to the end of our notes video. So thanks for tuning in. Don't forget to check off your notes sheet and get your practice sheet, and I will see you all later.